Welcome to the second session of my class on bridge course Mathematics, Vignan University. So in first class, I have discussed the very fundamental concept about the derivative and some real life applications. Also, I discussed the integration as antiderivative. So in this series of lecture, I will cover the following topics. That is basic concept of integration, definite integrals, the area bounded by curve, integration by parts, integration by substitution and using partial fractions, integration of trigonometric functions. After this lecture, you will be able to understand the concept and rules of integration, also evaluate some simple integration. So why I talk about the concept? Because concept in mathematics is very important thing. So for example, if somebody asks you what is a set, then what you will do? Your answer will be maximum 80 to 90% of you answer like this. So set is a collection of object or collection of things. But here we are missing one thing always, that is nothing but well defined. So if well defined is not there in your definition, then set is not defined properly. So that is why well defined. So set is always a well defined collection of objects or collection of things. Similarly, in integration, I will tell you a different definition. Like when a function f of x is known, we can differentiate it to obtain its derivative, that is df by dx. And the reverse process is to obtain the function f of x from knowledge of its derivative, that is nothing but your integration. So integration is a reverse process to find f of x if dfx by dx is given. So if derivative of a function, let us take is 3x square, f of x is given as 3x square, then how to find the f of x? So dy dx of fx equal to 3x square. So fx equal to what you get? Integration of 3x square dx equal to 3x cube by 3 plus c equal to x cube plus c. C is the integral constant. So c can be anything, any constant, right? And I told you the properties of this constant, right? I think you understood clearly. So I shown you a table. This table represents different formula for integration, general formula of integration, which we use frequently in our problem. Is it clear? Right? So in this, see one formula I have written here. Integration of x to the power n equal to x to the power n plus 1 by n plus 1 plus c for n is not equal to minus 1. Why n is not equal to minus 1 I have written? See, note that for x equal to n is valid for any value of n, maybe positive or negative or whole number or fraction, except n equal to minus 1. Because when you put n equal to minus 1, the denominator will be 0. Something divided by 0 is undefined. That is why n equal to minus 1 has been excluded. And when n is equal to minus 1, then we cannot integrate integration of x to the power n into dx. So now when n equal to minus 1, what happens? X to the power n will become 1 by x. And integration of 1 by x equal to what? Log x plus c. That is what we need to use it. So integration of x to the power 7 into dx equal to how much? X to the power 8 by 8 plus c. Right? One thing you should note, when dealing with trigonometric function, the variable x must always be measured in radians, not in degrees. Right? This is very, very important thing. Is it clear? Right? So integration of cos 5x dx equal to how much? Integration of cos nx dx equal to how much? Sin nx by n plus c. So integration of cos 5x dx equal to how much? Integration of cos 5x dx equal to sine 5x by 5 plus c. Let us see some rules of integration. First rule. Integration of k into f of x dx equal to k into integration of f of x dx, where k is any constant. So any constant is multiplied with a function f of x and we are integrating, then k must come outside, then integration of f of x dx you have to do it. Similarly, in some other rules, integration of f of x plus gx into dx can be written as integration of f of x dx plus g of x dx. Integration of f of x minus g of x dx is nothing but integration of f of x dx minus integration of g of x dx. So for example, integration of x cube plus sin x into dx equal to integration of x cube into dx plus integration of sin x dx equal to 1 by 4x to the power 4 minus cos x plus c. That is what we got it, right? So I have given one problem, you can try it, and my mail ID is there below. You can check it, or you can put in my comment. You can, any comment you will give, I will be answering to that. So find integration of 3 to the power t to the power 4 plus root over of t into dt. Right? This you can try. If you get any problem, you just comment or mail me. Mail ID I have displayed below. Another thing is the hyperbolic sine and cosine function, sine hyperbolic x and cos hyperbolic x. So sine hyperbolic x can be written as e to the power x minus e to the power minus 6 divided by 2. Cos hyperbolic x equal to e to the power x plus e to the power minus 6 divided by 2. Now if you want to integrate sine hyperbolic x into dx, then integration of e to the power x minus e to the power minus 6 divided by 2 into dx. Now use the property. Since subtraction is there, you can separate it. 1 by 2 take outside, integration of e to the power x dx minus integration of e to the power minus 6 dx. Right? So integration of e to the power nx is how much? Integration of e to the power nx divided by n. So integration of e to the power x is how much? Integration of e to the power x equal to e to the power x. So you will get integration over e to the power x dx minus 1 by 2 integration over e to the power minus 6 dx equal to e to the power x by 2 plus e to the power minus x by 2, because minus and minus will become plus. So we will get 1 by 2 into the power x plus e to the power minus x plus c equal to cos hyperbolic x plus c. Similarly, you can try some of the functions I have given below, right? So try it. This is for your practice. If any doubts, you can put in comment so that I can proceed in the next video. So these are all about the indefinite integral, because the integral constant is there in each and every answer. Now we will come to the definite integral. In definite integral, so called because the result will be definite answer, usually with no constant of integration. It is denoted as a to b integration over a to b f of x dx, where b is the upper limit, a is the lower limit. It's called the definite integral of f of x from a to b. The numbers a and b are, a is lower limit, b is upper limit. So if you integrate it, integration over a to b f of x dx, then we can write capital F of x, where capital F of x is nothing but the integration of f of x. So capital F of x at b minus capital F of x at a. So f of b minus f of a. So since b and a both are constant, definite and defined, f of b minus f of a also you will get a constant term. Right? You will get a constant term or a definite term. Right? That is why we call it as a definite integral. Yeah. So find the definite integral of x square from 1 to 4. This is an example, you can check. Find 1 to 4 x square dx. We know that integration of x square dx equal to 1 by 3 x cube plus c. But here our limit is given 1 to 4. 1 is lower limit, 4 is upper limit. So 1 by 3 x cube plus c at 4 minus 1 by 3 x cube plus c at 1 by 3 x cube at 1. Is it clear? So here f of x equal to x square and f of x equal to x cube by 3, right? So x cube by 3 at 4 minus x cube by 3 at 1. So 4 cube by 3 minus 1 cube by 3 is nothing but 21 is the answer, right? So this is very simple, right? So here upper limit and lower limit are given, so that is why we have done in this way, and this is called your definite integral. So these are the things we have covered. So similarly we can do for different various types of functions, right, with different types of rules. So next class we will continue the rules, right, what are useful for finding the definite integral. Yeah, so for the time being, you be in touch, give comments, and any concept or anything you want to put to my mail ID, you can put it, right? We'll be in touch. Thank you. Thank you very much for your patience.